Alright, today we're going to be doing a practice problem for Lagrange error bound. So this is the formula, that's Lagrange error. And then our problem is determine the degree of the Maclaurin polynomial required for the error in the approximation of the function at the indicated value of x to be less than 0.001. So this is our function sine, and our indicated value of x is 0.3. So, a Maclaurin polynomial, we know that it is centered at 0. So we know that c is equal to 0. And we know that the x is equal to 0.3. And now if we look at the equation, we know that the max, the f of n plus 1 z, we know that if we differentiate sine multiple times, we know that it will either be cosine, negative sine, no matter what, and this has to be equal, the maximum of the value has to be equal to 1. We know that because sine and cosine, the highest value could be is 1. So now we just have one variable that we don't know, which is n, and that is your question mark. And also the r of n of x is what we are trying to find it, and r of n of x, absolute value, needs to be equal to 0.001. So now we have all of these given requirements, and we just plug it in to the equation. So we know that 1 all over n plus 1 factorial, and then we know that 0.3 n plus 1, it needs to be less than or equal to 0.001, right? So now, by trial and error, you just need to plug in different n's, so 1, 2, 3, 4. You should get something that is less than or equal to 0.001. So the first n that you get that's less than 0.001 is your answer. So I already found that, and by trial and error, you get, the answer is n equals 3. And at n equals 3, it is less than or equal to 0.001. So that is the degree of the Maclaurin polynomial required for an error of the function, approximation of the function, to be less than 0.001. And anything greater is, obviously, will be less than that too. So